Hello everyone, welcome to Learn Overflow. In this video, we'll look today's LeetCode problem. It is the average of levels in binary tree. So this is an easy level problem and we'll understand what this question is asking us to do. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. So the question says we are given a root of a binary tree. So that's a root of binary tree being given to us, and return the average value of nodes on each level in the form of an array. Like on each level, whatever the average value of the nodes, we need to return that in the form of an array. And the answer is within 10 to the power uh, -5 of the actual answer will be accepted. Okay, so this is kind of a not constraint, but kind of a limit we get to know. Fine. That's not a big deal. But what we need to do, we need to return the average of the nodes on each level in the form of an array. So once we are clear about this idea that we need to do something on each level, okay, like this is a level, this is a level, and this is a level, right? Once we are clear about this, then we need to go ahead with each level. Then we are sure that this there is no better algorithm than a breadth first search, because a breadth first search helps us in traversing in each levels fast, then in a much depth way to traverse. Okay, first all the breadth are traversed. So that's the the whole the common sense we should get out of it. Fine. Now this question, if you look carefully, this is a classic breadth first search example. Fine. So this breadth first search example, we get to see the exactly what breadth first search and how it works. So if you're not sure about its algorithm, we will be exactly using the algorithm, and just additionally we'll use a sum variable. This sum variable will sum up all the values in the particular the particular level, and then we'll add this values sum variable divided by how many variables were there in the particular level, and we'll store them in our array. Okay, that's the least they say, but okay, whatever. We'll store them in our list. Okay, so that's the pretty much extra we'll do, but else it is a classic breadth first search problem. Okay, so at each level, compute the average. Like since you already know the size of each level, so simply compute the average and store them in the store them in our list. Okay, so that's the pretty easy solution. Let's quickly write it down, write our breadth first solution, and then understand how our breadth search is actually working. Okay, so always remember, whenever we try to do anything with breadth first search, we will be using a queue that will store each of the sub nodes, or each of the child nodes of each our current node in a queue. And once our particular level is traversed, we will then go ahead to the next level with the help of those child nodes that we stored in our queue. Okay, so that's the idea, more or less. So let's write this reference algorithm down, and then we'll again understand how the algorithm works more or less. Yes, so there you see, this is a code that works good for us. So this is a classic, as I said, this is a classic example of breadth first search. Okay, so let's see what exactly we did. So the first one is we took our answer variable. So this will be the final answer we are returning. Okay, the double type list we have. Okay, fine. Then we took a queue. This queue is more or less a linked list that will help us store all the uh, current nodes in the current nodes in our current level. Okay, so that's the idea. Further, what else? We are first checking that if root is null. Okay, if in case root is null, we are simply returning answer that is a blank list. Okay, then what if the root is not null? We simply add the root to a queue. Okay, so that means the queue has some value that is a current root. If you look carefully, current root means this initial value. Fine. Uh, so here we add it. So let me just show you. So current root means in the initial stage, this root of the whole array or root of the whole, you know, oops, yeah. So root of the whole uh, tree is there initially, fine. And then what do we do with that? Further, we simply go ahead and write it like while our queue is not empty. That's a continuous while loop being started, and this will end only when we are reached with the final answer. So while our queue is not empty, for each of the like we keep on checking, and first thing we did, we just like note down the size of the queue. Why is it so? So that we keep a track of our current levels, right? Current levels being current of like the current level in the sense, the current uh, like state or the current height we are at. Okay, so how many elements at our current level? We just keep a note of that using the size. So we just make note that this should be our size. Now, further, we take the sum variable as 0 0.0. It's a double type variable. Okay, so we should add some answers, right? Like their average new answer. So we just initially took it as a double type variable. Now, what will happen? We are at like we are just running a loop from 0 till n. So if this our further we will keep adding our other elements to a queue, so we keep a check that only the first n elements are those which gets executed, like which gets popped up. So what do we do? We just run a loop for all the first n elements, and we take a tree node variable node, and we pop our like poll our queue values. Okay, one by one we queue n the number of values. Fine. So in that case, what will happen once we keep polling those values? We are sure that only the n elements are moving out. Why? Because here, like below, we will do something. We'll add more values in our current queue as well. So once we polled our value, we simply add our node dot val to our sum. Okay, we just add it to our sum variable. And what we are doing further, which is the current node that we popped or polled, if its left is not null, we are adding it to the node dot left is being added to the queue. And if our right is not null, like node dot right is added to the queue. Fine. And once we just do something like that, and further, what we do, we simply like once our all the n elements are getting added and all the left right are also added to our current queue. Okay, so once it's done, we simply add our answer like uh, add this sum by n. So the average is being added to our answer. That is the current results. Okay, level order average, what do you say? Okay, at each level average, we just add them to our answer, and ultimately once we find like traversing through the whole tree, once our tree becomes empty, we simply return answer. We simply return the answer that we created. So that was the whole idea behind creating this answer, right? So that's how that breadth first algorithm works. This is exactly how a breadth first algorithm works. Just a additional statement was like this statement, right? This adding to the answer. So that's the additional statement. Else, if you look forward, this is exactly for how your breadth first algorithm works for us. Okay, so that's more or less it, guys. So I hope you can understand how this breadth first algorithm works, and uh, that's also the idea. So if you have any doubts related to this, make sure to comment down in the comment section below. I'll be happy to help you out in the comments as well. Also, subscribe to this channel for regular LeetCode videos like this. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.